Assalamu alaikum again, guys. So in this next lesson, we're going to be looking at sketching absolute value and square root graphs. So let's start off with absolute value graphs. We've got three styles of absolute value graphs that we're going to be looking at. We've got when we absolute value fx, when we absolute value the x, and when we absolute value the y. All right, they all result in some very interesting transformations. All the transformations are described immediately below each of their respective titles. All right, so let's just start with the first one. I'll be flicking up and down between these just to make sure that we are looking at the correct question. So here, to sketch y equals fx from the sketch of y equals fx. So look at this. This one's the easiest one. Everything above and on the x-axis stays the same. Everything below the x-axis is reflected back above the x-axis. So essentially what that means is if I have any part of a graph that's below the x-axis, that gets reflected up, but everything already above stays where it is. And that makes perfect sense. It makes negative values positive. Okay, that's what the job of an absolute value is. So again, imagine this is y equals fx right here. If I were to sketch the absolute value of fx, then the positives will stay where they are, but anything negative gets reflected back above the x-axis. Okay, so that's the first one. And now let's look at the next one. The next one is sketching y equals f of absolute value of x. So that we're just making the x values positive. So what essentially is happening here, let me do a graph like this. Actually, I prefer it this way. All right, graph like this. So basically, look what it says. Everything to the right of the y-axis stays the same. So it's saying this is all good. This remains as it is. But everything to the left axis, to the left of the y-axis is removed. So they delete it and replace it by duplicating what's happening on the right side. Okay, so they're saying this side is good, but everything on this side is gone and it's replaced by the reflection of what's going on this side. Okay, that's what happens. That ends up being your graph. So it's got to be a bit more pointy here in the middle. So it's got to be, because it's a sharp change. It's not necessarily a smooth change. Okay, and there we go. So basically everything that's happening here shows up here. The reason for that is when you absolute the x value, you're turning all these x inputs into these inputs. So for example here, this is -1 here. Well, it's going to take the y value of +1 on this side. This is -2 here. It's going to take the value of 2 on this side because you're absolute valuing this. So it's almost like your x-axis only contains positive numbers and 0. So there's no negative numbers essentially. Okay, so that was a bit trickier, but it's easy once you do a few examples. Okay, now here we go. To sketch y, absolute value of y equals fx. So the rule for this is everything above the x-axis stays the same. We delete everything below the x-axis and replace it by duplicating what's above the x-axis. All right, so this one here, if we have a sketch like this, actually we need a few more features to make it clear. Let's say that's our sketch. Well, basically everything above stays. And everything below disappears. So that means they're all gone. But then everything is repeated below. Like so. Actually, I'll try and make it as accurate as I can. And you get an exact replica or an exact replacement of the graphs in that way. There we go. Okay, so that's what happens in the third case. So hopefully that's clear. Let's get started on some questions and let's see how we go with this. So the graph of y equals fx is sketched to the right. To draw each transformation, copy the graph and draw the transformed graph in a different color on the same axis. Okay, so the first one right now these are all y equals fx, what I've got written in blue on each separate graph. All right, so part A asks us to sketch y equals absolute value of fx. Obviously, it instructs me exactly what to do, but we're just going to focus on this. It's asking us to sketch y equals absolute value of fx. Well, if you recall earlier, if fx is absolute value, then what we do is we take the negative part of the graph and we reflect it to the positive side. Everything else remains the same, so this is all good. We're going to keep this. We're going to keep this. But then we just reflect what's going on below, like that. And that's it. That's your graph. So in orange, I have y equals absolute value of fx. As straightforward as that, guys. It's really, really simple. Okay, let's look at question B. So question B says, let's ignore the instructions because we've already looked at the instructions. Let's look at y equals to f of absolute value x. So if you recall, this one is telling us to reflect the graph about the y-axis. So it means we keep all of this. So all of this is kept. I should do that a bit more plainly. We keep all of this, but then we remove the rest of it and draw it like that. So we get this W shape. Okay, so I'm going to use a shortcut here. All right. And this one here. My apologies, just trying to make it as accurate as possible. Okay. All right, there we go. So the orange graph is the replacement graph. So this here is y equals to f of absolute value of x. Okay, so hopefully that made sense. And now finally, again, the question is instructing us. We're just going to focus on this. We're going to do the absolute value of y equals fx. So let's come down. I'm probably going to need a bit more room in this sketch. So I'll stretch this down a tad. I'll bring this down a bit. Plot in the extra numbers that I may need for my sketch. I can probably go a little bit further. The reason I'm including -4 because we've got almost the same intercept here at 4. All right, so again, with absolute value of y equals fx, the rule was telling us we keep everything above the x-axis. We delete this part, and then we reflect the same graph below. Just like that. Maybe we got too much curvature on that one. There we go. All right, so that's it. That there is absolute value of y equals f of x. So hopefully that's quite clear now. We've got the 3 transformations from the same graph. The absolute value of fx, you just reflect whatever's in the negative portion to the positive portion. Y equals f of absolute value of x. That means we just ignore any negative sections of the graph. So all of the negative parts are ignored, and we just reflect the right side of the graph to the left. And then finally, the absolute value of y equals fx, we just reflect what's above the x-axis to below the x-axis, as demonstrated in part C. All right, let's move on to another example. So I've pre-prepared these questions here. So we're going to use this graph, and again, we're going to repeat the same graphs or the same techniques. We're going to do the absolute value of y fx. So we'll start there, y equals absolute value of fx. Then we're going to do the absolute value of x for f. And then finally, we're going to do the absolute value of y equals fx. So let's start off with absolute valuing this. Nice and easy. I keep everything above the x-axis. Anything below the x-axis, I'm going to reflect it back up. And there we go. Done. Nice and easy. All right, this one here. We're going to reflect the entire right side to the left side. So we keep the right side. So if the x is absolute valued in the function notation, we keep the right side and we reflect it in the left side. And there we go. Be as neat and accurate as you can. And then finally this one here, the absolute value of y equals fx. We keep everything above the x-axis. And this time we reflect what we've kept. There we go. As simple as that, guys. All right, the next section, we're going to actually draw our sketch first and then apply the transformations. So you have to know how to draw your graphs. You have to know functions quite well. We will be exploring functions in great detail soon in advanced maths, but for the time being, you have to recognize some basic graphs. This here is a hyperbola with an upshift of 1 unit and an asymptote at x equals 2. So let's get that sketch going in. I'll just copy paste this and delete any of the other graphs. Okay, so that's improvising there. Let's bring this down a bit so we've got some room. All right, let's choose a unit. We're going to make this x equals positive 2. This is the asymptote because remember we're not allowed to equal x. We're not allowed x to equal to 2, so that's going to be 2 right there. We have this plus 1, which is an upshift of 1 unit, so that's going to be my horizontal asymptote for this hyperbola. And if I test, let's test 1. If I put 1 in here, I get 1 over negative 1 plus 1, which is 0. So that means x equals 1 is intercepting right there. Also, if I put x as 0, I get negative half plus 1, which is half. So I get a y-intercept there. So this kind of tells me the shape. I do that just so I'm clear on what shape I'm drawing. And it tells me that the branches of the hyperbola, one of them's here, and the other one's there. If I can just draw this properly. There we go. And then the other one's up here. I'm going to try and get a decent shape so we can draw nicely. All right, there we go. I think that's a good shape. There we go. So that there is our function y equals 1 over x minus 2 plus 1. It's denoted as fx for now, so I'm just going to keep that. Let me put in these x-intercepts that we had earlier. Okay, so this is the original graph. I'm going to use this to help me sketch parts B. Parts 1, 2, and 3. So let's go ahead, copy, paste, So I've got this B1, we're sketching y equals to the absolute value of fx. Okay, so now I've got my graph here. Basically anything below the x-axis is going to become positive. So all of this section will be reflected to there. I'll keep everything else, so let's just keep the originals. So far so good. And now we bring up this. There we go. So that there is y equals to absolute value of f of x. All right, perfect. Now let's do the next one. Y equals f of absolute value of x. I'll just need to insert a new page. So B2. Let's take that image from before. We're doing y equals to f absolute value of x. And this one is just reflecting whatever's on this side to that side. So there's quite a bit of work here for us. I've got to reflect the asymptote. So let's bring in the asymptote here. So now this would be at -2. I'll have an intercept at -1. So again, we're going to keep all of this. We've also got half happening, yep. So we're going to keep all of this. So this time we keep the right side. And then I have to do an exact replica of the right side here. Let me move the -1 for a second. So -1 is drawn here. And then we get the final branch being drawn here. So just need a marker there. And there we go. So that's y equals to f of absolute value x. All right, let's do one more example. My daughter's just walked in. Don't mind her. All right, so this example, we're looking at the absolute value of y equals fx. Okay. So the absolute value of y equals fx tells us to keep everything that's above the x-axis. So we keep everything that's above the x-axis. We essentially delete everything that's below the x-axis. And then we reflect whatever's going on above below. So I'm going to keep all of that. And now I have to do the difficult task of redrawing everything that's above below. All right, and there we go. And now I've just got to do that branch of the hyperbola. Probably could use with a bit more hyperbola space. No? Okay. All right, there we go. That's the graph of the absolute value of y equals f of x. Okay, so as you can see, it's pretty easy topic. A bit of work required, but nonetheless, it's quite straightforward. Now, let's get into some tricky stuff here. All right, so this is square rooting a graph. This is a bit more trickier. As you can see, there's quite a lot of rules. I'll leave the rules there just for you to have a quick look at, but I'm just going to show it the way I do it. Some of the most important features regarding it, it's better shown through demonstration rather than reading, and I'll explain them as we go through it. All right, so first part here, use the graph of y equals fx to sketch y equals to the square root of fx, and then for the second one, y squared equals fx. All right, so basically, when sketching y equals to the square root of fx, you have to keep this in mind. You're essentially square rooting the y values. So whatever y values you're evaluating on the graph, you're square rooting it. So this here is like might be a half. That there's a 1, the square root of 1, the square root of half, the square root of a quarter. That's essentially what we're doing. And some very unique things happen when you're square rooting numbers that are less than 1. If we're square rooting a number that's bigger than 1, we know that the number gets smaller. Like, for example, the square root of 9 is 3. So if any number above 1, so this is the threshold, any number above 1 will actually come lower. All right, it'll become smaller. But when we're square rooting for numbers that are less than 1, then the numbers actually get bigger. Think about this. We have a quarter. If you square root a quarter, later, when we're square rooting a quarter, we actually get a bigger number. That's a half. If you recall, a quarter is 0.25, but a half is 0.5. So it's actually bigger. So these are just some of the interesting properties and behaviors that occur when square rooting numbers less than 1. So let's give this a shot while keeping that in mind. So all of this is less than 1. All of this here is less than 1. And if the number is less than 1, then they're going to be bigger. But this here is 1. So let me ask you a quick question. What's the square root of 1? The square root of 1 is 1. So that's the first point that is the easiest to evaluate. We're going to have 1 equaling to 1. The square root of 0 is also 0. So that means we have 0 and 0 as well. So let's keep our focus on this section here. As I said earlier, the numbers are actually a little bit bigger. So look at that. I've drawn the graph slightly bigger in those sections. All right, there we go. And furthermore, let's look at this value over here. So notice we have I've lined up with 1 here. That means all of these values here are less than 1. So that also we've got a 0 value here. So that means all of these values are slightly bigger than them. See that? But something interesting happens. Once we hit that 1 value, the graph actually goes less. If I had extended this a bit more, you would see that all those numbers start to become smaller than their counterparts. So this graph will be going up, but this one will actually start going down. It's only between 0 and 1 is that the square root graph is bigger. Now you may have noticed that I completely ignored some values. These two sections here. And the reason for that is you cannot square a negative number. You cannot square root a negative number. So no values exist under here. Therefore, my finished graph is the orange parts of the graph. Okay, so that's the trick here. So real quickly, our takeaway from that was, we've got a few. Fx equals 0, then square root fx equals 0. Fx equals 1, then square root fx equals 1. If fx is greater than 1, then square root fx is less than fx. I just need to make this a bit smaller to make it fit. And if fx less than 1, then the square root of fx is greater than fx. So those are some of the most important things to remember when sketching square root graphs. Okay. All right, now the next interesting graph, y squared equals fx. Well, if you think about it, y squared equals fx is basically y equals to plus minus square root fx. It's basically the square root fx graph, but because of the minus, it means that we mirror it on the same axes. So watch what I'm going to do to sketch the square root of this. I'm actually going to copy paste my results from the first question. Duplicate. I'm going to paste it right there. Paste it right there. Just need a bit more accuracy. There we go. And then I'm going to reattempt to draw these below. That's what happens when you use y squared. You do the square root graph. So if a question asks you to do y squared equals fx, you do the square root graph, and then you draw the same thing on top and the bottom, and that's it. So that's what's nice and easy about understanding this y squared equals fx graph. So the note for here is, after completing the sketch of y equals square root fx, because you have to do that, let me make this small. Actually, I need to make all of this smaller. So after completing the sketch of y equals square root fx, mirror the sketch about the x-axis to get y equals negative square root f of x. This will give you y squared equals fx. And that's that. Hopefully that wasn't too confusing. It's a lot easier to show by demonstration rather than making you try to read all that. But read that, you still need to understand some more intricacies. They talk about x approaching infinity and all that. It's that's quite easy to understand. The harder thing to understand is that above the value of 1 and below the value of 1. That's probably the hardest thing to understand here. But let's move on. So now I've got to sketch this graph. Okay, I just had to plug my charger in. So now we're going to sketch this graph from scratch. Fx equals 2 over x minus 2 plus 2. That's very similar to the previous graph we did. In fact, I'm going to pinch that as I don't feel like drawing. copy. Beauty of using an iPad. All right, what I need to do, I need all of this. Hopefully this works. I just need to shift it up by 2 units. And then I can adjust everything else. All right, because if you notice, it's got the same asymptote, which is perfect for me. All right, I think that's quite good right there. Clean that up. There we go. I'll need to extend this part here a bit. All right, perfect. So now let's get the x and y intercepts. X equals 0. We get -1 plus 2, which is 1. So the y-intercept is 1. That's a bit high. No, we can deal with that. 1 should technically be here if I've chosen that scale. Let me just see if it's going to annoy me to do it. There we go. We can deal with that. And if we look for the x-intercept, that will be I have to work it out. All right, that's also 1. So the graph is a bit inaccurate in this format, so I have to change it. So it goes through 1 on both sides. Well, in the end, I still had to end up drawing it. Sorry for wasting your time. All right, there we go. All right, that would mean this would look significantly different, but we'll just run with it. So we have this. We're going to apply the square root first. So let me duplicate this graph. So this would have been part A. This is part B1. So the square root of this graph, everything that's positive. Oh, by the way, this is 2. I forgot to label that. That is 2. Everything above the x-axis gets square rooted, including the asymptote. So the asymptote is no longer 2. The asymptote is going to be the square root of 2, which is about 1.4. So somewhere around here. So it's very important that you understand that. Even the asymptote gets square rooted. Literally everything. The horizontal asymptote, that is. The vertical asymptote will stay as it is. And then I just do the same sketch. Actually, it's got to be a bit more compressed. So it'll be drawing in closer to the graph like this, because their values are smaller. All right, perfect. And now, for the next part, this value 1, we actually going to intercept with that, because we noted earlier that the square root of 1 is 1. So we're actually going to be intersecting with that. But on this part here, these numbers are all bigger than 1. So they're actually going to be below the other graph. And by default, the asymptote has sort of blocked it from moving to there. But watch what happens here. We end up with the same x-intercept. Wait, do we? Yeah, we end up with the same x-intercept, but in this region from here to here, we're still above the other graph. There we go, just like that. See that? We're still above that. And then we do not continue this. Why? We can't have negative square roots. So all of this is invalid here. And therefore, that's the conclusion of my graph. Okay, so that there is y equals to the square root of fx. Perfect. All right, then from here, we're going to sketch y squared equals fx. And I'm just going to use the information from this graph, because what you need to do is sketch fx, the square root of fx, and then we sketch the negative square root of fx. So right there, everything above the x-axis, that's the square root of fx. And following as per the instructions earlier, after completing the sketch of y equals square root of fx, mirror the sketch about the x-axis to get y equals negative square root of fx. This will give you y squared equals fx. So all I have to do now is sketch the bottom half exactly in the shape of the top half. So we're going to end up with a y-intercept of -1. Oh yeah, and to that we're also going to end up with the asymptote square root 2. I forgot to write in the above one, so that's square root 2. We have negative square root 2 as well. All right, there we go. All right, so that's there. And then finally, I mirror this exactly as well. And there we go. That's my sketch of y squared equals to f of x. And finally, we're done. So I know that was a bit of a handful, but that's what we need to have completed for this week. If you have any issues or concerns, just go back to the video, pause, repeat, analyze what's going on, but you should be fine with all of that. All right.